Hey everyone, welcome back. Thank you very much for joining. Today we are going to be having a look at conditional statements and conditional operation. So far we've covered printing, reading inputs, variables, calculating with numbers, and then we're going to, like I say, have a look at conditional statements and conditional operation. So the learning objectives are to become familiar with the idea of a conditional statement and know how to create a program containing optional operations through the use of conditional statements. Become familiar with comparison and logical operators commonly used in conditional statements. Know how to compare both numbers and strings, remembering the equals command for strings. Become familiar with the order of execution for a conditional statement and know that the passing of a conditional statement stops at the first condition whose statement evaluates to true. Okay, so we'll get to all of that, and that will get a bit more context as we proceed through this course, or this tutorial. So our programs so far have been linear. In other words, the programs have executed from top to bottom. Without major surprises or conditional behavior. However, we usually want to add conditional logic to our programs. By this we mean functionality that's in one way or another dependent on the state of the program's variables. To branch the execution of a program based on user input, for example, we need to use something known as a conditional statement. The simplest conditional statement looks something like this. So this is a very, very basic if statement, and what we're saying is that if it's true, this piece of code here will print. Okay, and because it is true, it's evaluating to true, which means it prints, which is a bit funny way to put it, but yeah, so that will always print because it will always be true. A conditional statement begins with the keyword if followed by parentheses. An expression is placed inside the parentheses, which is evaluated when the conditional statement is reached. So if we just look here, we've got our parentheses, so there's our if statement followed by a parentheses and then a condition inside. The result of the evaluation is a Boolean value, so no evaluation occurred above. Instead, a Boolean value was explicitly used in the conditional statement. So this true is the Boolean value, and because it evaluates to true, that's why it's printing out. The parentheses are followed by a block which is defined by opening curly braces, so open curly brace and close curly brace, which are shift and then next to P and enter on your keyboard. The source code inside the block is executed if the expression inside the parentheses evaluates to true. Let's look at an example where we compare numbers in the conditional statement. So we've got int number 11, so the value 11 is assigned to the integer variable number, and what we're saying here is that if number is greater than 10, we will do this systemout.print the number was greater than 10. So because number is 11, it's definitely greater than 10, so this will print out. If the expression in the conditional statement evaluates to true, the execution of the program progresses to the block defined by the conditional statement. In the example above, the conditional is if the number or variable. In the example above, the conditional is if the number in the variable is greater than 10. On the other hand, if the expression evaluates to false, the execution moves onto the statement after closing the curly bracket of the current conditional statement. And there's a note here, an if statement is not followed by a semicolon since the statement doesn't end after the conditional. So what they're saying is that there's no semicolon on this line because it evaluates the condition here, so it's enclosed in these curly braces like a block of code, like a method. So we need to write a program that asks the user for an integer and prints the string speeding ticket if the input is greater than 120. So we're going to need to write, I'm going to pinch this like I usually do. Let's grab that. I'm going to minimize this and open my Netbeans. And we'll get started. Brill. So we've got our Netbeans open, we've got our speeding ticket here. There we go. I'm just going to see if we can change the theme. Let's see. So you can put dark modes and things on if you like. I usually use one called Darcular. Let's see where it is. I'm just gonna, before we get started, change my theme. So I've downloaded the Darcular theme. I'll put the link in the comments if anyone else wants to use it as well. Of course, I will pop that there for you. We'll just quickly get that installed, and then we will crack on. Okay, we won't crack on quite that quickly then. We'll have to restart Netbeans first. Okay, that's better. I quite like that. I think that looks a lot better. I'm just going to quickly increase my font size as well. Just hopefully it makes it easier for you guys to see what I'm doing. So its default is 13, and I think I normally set it to 18. So let's do that. Let's have a look. That looks quite good. So hopefully that's okay. Okay. So I'm going to quickly head back here, pinch this, and I'm going to paste that in here. So we need to firstly start with a prompt. So we're going to use our S out, and we are going to say give speed. So give speed with capital G, everything else lowercase. Perfect. So what we're also going to need is somewhere to store the speed and some way of accepting that input from the user. So at the top here, I'm going to put a scanner in. I'm just going to call mine SC because it's easier than writing scanner, but you can call yours whatever you want. So scanner SC equals new scanner, and then it's system.in. There we go. And then the reason we've got these red underlines, in fact there's two reasons. One, I'm in the wrong class, I'm in sandbox for some reason. But the other reason is because we just need to do an import. So here. But anyway, let's copy this. Let's cut that and go back into here. There we go. Oh, and they've already put the scanner in for us. Discard the changes for that. Cool. Right, okay, let's start this again. So I paste that in, delete my scanner because they've already given us one. System.out give speed. So we need our integer, don't we? Somewhere to store our speed. So I'm going to call mine int speed, and then we can say that that's equal to scanner.nextInt. Now this is going to be a bit of a test because normally we use the value of method, but I'm just curious to see if this is going to work. So first I'm going to start with this, and then we need to put our conditional statement in. So this is where we're going to start something a bit new. So we're going to say if speed is greater than 120, then we need to issue a speeding ticket. So I'm just going to cut this, put an S out, and then, oh, that went a bit wrong, didn't it? S out, there we go, and then paste it in. Okay, so just to, because we're starting to get quite a few curly braces now. So when you click on a curly brace, it will highlight the corresponding brace. So if you click on a close, it will show you the open. If you click on an open, it will show you the close. And quite often it can be useful to add some comments on. So here we can say this is the end of if statement. This is the end of the main method. And this is the end of the class. So normally when I'm teaching new students, I always put on do not write past this point or beyond this point. Cool. So let's just add a bit of space in. So if we wanted to add more information to our method, to our main, we would put it in between these two curly braces. If we wanted to put another method in our class, we would put it in between these two curly braces. Okay. So let's give this a run and let's see how it goes. So it's just loading up there. There we go. Excellent. So it's asking for a speed. I'll just do 121. Excellent. That's great. Let's just actually double check what they've asked for. So if the speed is greater than, okay, so what I was thinking there is if it's equal to or greater than, which is different code. So that's fine. Well, I suppose it would be greater than or equal to. Right, let's give this send off, see how it works, and see if this little test, see if that works as well, because it'll make it a bit easier for us when we're writing scanners if we can do it this shorter way. Oh great, so it has come back as a pass, so that is good. Oh look, they got model solutions as well, I didn't know that. Brill. Oh, you need to sign in. Let's have a look and see what they say. Interesting. So they've put a blank line in theirs, and they're using this integer dot value of, rather than what we were using. But that's good to know. It's nice to see that we can view an answer as well after we've submitted ours. So if we resubmit that, we've got our point, and we can move on. So code indentation and block statements. A code block refers to a section enclosed by a pair of curly braces. The source file containing the program includes the string public class, which is followed by the name of the program and the opening curly bracket of the block. The block ends in a closing curly bracket. In the picture below, the program block is highlighted. So this is kind of very similar to what we've just done. So on our example, so if I just move this to the left and move that to the right, we can see that here our project name is speeding ticket, so that's the name of our class, and our open and closing curly brace are up here and down here, and we've already put this note on end of class, so that's another bit of context to add to that. Okay, the recurring snippet public static void main in the programs begins a block, and the source code written within it is executed when the program is run. This snippet is in fact the starting point of all programs. We actually have two blocks in the example above, as can be seen in the image below. So all of the code that we've been writing so far has been in our main method here, and that's been contained within the outer class. Okay. Blocks define a program structure and its bounds. A curly bracket must always have a matching pair. Any code that's missing a closing or opening curly bracket is erroneous, and what that means is it will just show an error. So if I quickly pop back here, so if we delete this curly brace, you can see we get an error here. We put that in, and then if we delete an open bracket at the end here, you can see that we get an error as well. So they always need to be matching. For every open bracket you put in, you need a closing one as well. A conditional statement also marks the start of a new code block. In addition to defining the program structure and functionality, block statements also have an effect on the readability of the program. Code living inside a block is indented. For example, any source code inside the block of a conditional statement is indented 4 spaces deeper than the if command that started the conditional statement. 4 spaces can also be added by pressing the tab key, which is just to the left of the Q on your keyboard. When the block ends, for example, when we counter the closing curly brace, the indentation also ends as well. The closed curly brace character is at the same level of indentation as the if command that started the conditional statement. So here we've got this example, and that is incorrectly indented because number 9 needs to be moved over 1 tab space. So I'll just quickly copy that and I'll show you here. Make that a bit bigger. There we go. So if I paste that in, so I'll just put it in here. So what we've got, the problem with this is because we haven't got a variable called number, so that's fine, we know about that. But what needs to happen is for that line here on 17 needs to be indented like that. Okay, so that's correctly indented. And what we've done above here is correctly indented as well. Okay, so I'll just delete that. There we go, and I'll head back here. So the example below is correctly indented. Okay, there we go. So we've got that perfect example. Code in Java is indented either by 4 spaces or a single tab for each block. Use either spaces or tabs for indentation. Do not use both. The indentation might break in some cases if you use both at the same time. Netbeans will help you with this if you hit the Alt, Shift and F key combination. From now on, our program code needs to be indented correctly in the exercises as well. If the indentation is incorrect, the development environment will not accept the solution. You will see indentation errors highlighted in yellow in the test results. The above error message says that there should be 8 spaces at the beginning of line 8, and there were only 2. We can fix the indentation by adding 6 more spaces to the beginning of line 8. Okay, let's see. So here we have an exercise to check our indentation. The exercise template contains a program demonstrating the use of conditional statements. It is, however, incorrectly indented. Try to run the tests before doing anything. TMC shows the indentation errors differently compared to errors in program logic. When you notice how indentation errors are shown, correct them. Now would be a good time to give the automatic code formatting a try. Okay, so it was Alt, Shift and F. Let's see, so let's close this one down. And then this one, check your indentation, 20. So that's this one, check your indentation. There we go, let's see. Okay, so let's give that a run, and then we should get those yellow errors back saying that the indentation isn't correct. Okay, so here is our errors. Well, that's actually really good because it's telling us exactly what line has the issue, what the expected indentation should be, but actually what it was as well, so that's really cool. Okay, so let's select all of this and then press, was it Control Shift and F, I think? Oh, there we go. Oh, no, that's not it, that's Find in Projects. Maybe it was Control, Alt Shift and F, let's try that. There we go, so that's indented some of it, but it hasn't, oh, it has indented it correctly. Excellent, oh, that's really useful, I didn't know that. Cool, so if we submit that now, it should come back all good. Fantastic, so that came back and has all passed. Excellent, we'll get that sent off. Let's close this one down. And let's go back here. So if we refresh that, we should have our points. Excellent. So now we're looking at comparison operators. So these are what we use within our conditional statements to provide a way to compare our conditional logic. So we've got a greater than or equal to, less than or equal to, double equal for the equal to, and exclamation mark and equals for not equal to. Okay, so int number is equal to 55. So note here they only used one equals sign. So remember, the single equals sign assigns value to something. So when you're using equal to in comparison, you need to use double equals. So what we've got here is if number does not equal 0, remember, not equal to, systemout.println, the number is not equal to 0. If the number is greater than or equal to 1,000, systemout.print, the number is at least 1,000. And then we've got this output here, because 55 does not equal 0, so that's evaluated, but also it's less than this number, so that wouldn't evaluate it to true. Okay, so let's have a look at this. Write a program that prompts the user for an integer and prints the string Orwell if the number is exactly 1984. Okay, let's pinch this. Let's go back to our TMC Netbeans. Won't be long, we'll be starting on part 2. Should be great fun, I'm sure. So let's paste that in. So as always, we need to start with our system out. So we'll start with a user prompt. Give a number followed by a colon. We'll need an integer, so somewhere to store our number. So int scan is equal to scan.nextInt. You could obviously use the dot value of if you like. That is not a problem at all. What have I done wrong here? Oh, there we go. Int inputs, because I gave it the same name, so it didn't like that. Okay, so our conditional is going to be if input is equal to 1984, we'll print out Orwell like that. Okay, so notice here we've got our double equals. We don't have any quotes, single or double, around integers. We don't need that. And I'll just put a couple of notes on here just so it gives a bit more context to you guys. So we've got end of if statement, end of main method, and then this is the end of our class. Okay, so let's give that a run, see how we do. Excellent, another one passed. That's great. Let's OK that. Close it down and head back to our program here. So write a program that prompts the user for a year. If the user inputs a number that is smaller than 2015, then the program prints the string ancient history. Well, that's depressing if 2015 is ancient history. But let's give this a copy and go to our ancient history class or project. There we go, and then I'll paste that in here for a little reminder. Excellent. So this is going to follow a very, very similar format to the previous example that we looked at. So we need a prompt, so give a year followed by a colon. We need an integer to store our input, so like that. And then we'll say scan.nextInt. Excellent. And what are we going to do now? So now we need our if statement. So we'd say if input is less than 2015, then we're going to print out ancient history. So ancient, lowercase h, history with an exclamation mark. Brill. And then I'll put my notes on again. So end of if, end of method, and end of main method, and then here we've got end of class. There we go. So let's give that a little run and see how we do. There we go. Look at that. Another one passed. So let's OK that one. Send this off. And head back to our exercises. Refresh for our points. Let's just have a little look. So there we go. Look at that. We've nearly got 100% on all of the first parts. That would be fantastic for starting the second part. Excellent. Okay, so now we're adding a bit more to our if statement. We're going to look at an else. So if the expression inside the parentheses of the conditional statement evaluates to false, then the execution of the code moves to the statement following the closing curly bracket of the current conditional statement. This is not always desired, and usually we want to create an alternative option for when a conditional expression evaluates to false. This can be done with the help of the else command, which is used together with the if command. So here we've got int number is equal to 4. If the number is greater than 5, system out print your number is greater than 5, else your number is less than is 5 or less. Sorry. Okay. So this is an extra condition, an extra bit of logic that we can look at for our program. If an else branch has been specified for a conditional statement, the block defined by the else branch is run in the case that the condition of the conditional statement is false. The else command is placed on the same line as the closing curly bracket of the block defined by the if command. So here we've got our open curly bracket for the if, and this is the close curly bracket for the if, and then open for the else, and then close for the else. Okay. So what have we got? Write a program that prompts the user for an integer and informs the user whether or not it is positive or negative. Okay. Okay, so they're saying greater than 0. Okay, that's good. That's good to get that. Let's just pinch this. Go back to Netbeans and open our positivity package. Okay, so let's start with our prompt. So prompt our user, give a number, and then we need our integer, So we'll say int input is equal to scan.nextInt. And now we need our if. So if input is greater than 0, so we'll say sout that number is positive with a full stop, else, what was the else? I can't remember what the else was. The number is not positive. I should really have been able to remember that. Else, there we go, the number is not positive. So let's delete this. So again, very similar to before, this is the end of our if and else. Still the end of our method. And at the bottom here, this is still the end of our class. Okay, so let's give that a little run and see how we did. Fantastic, so that's another one in the bag. Excellent, let's close this down. And let's have a look at another example. So here we've got adulthood. So write a program that prompts the user for their age and tells them whether or not they are an adult, so 18 years or older. Okay, right. Finish this. There we go. Excellent. Right, so again, we start with our prompt. So we'll say, how old are you? Question mark. Then we need our integer to store our input. So int input is equal to scan.nextInt. Like that. Whoops. Like that, sorry. And now we need our if, and then we're going to use our else. So if input is greater than 18, system out, you are an adult, and then we've got our else, system out, you are not an adult. Okay, let's get rid of this. Just double check that first system out, I've put the correct word in there. So you are an adult and you are not an adult, that's great, I think I've got that. Cool, let's get this one submitted. Okay, so this is quite a good error to get actually, because it shows us the extra conditionals we can add in to make our code a bit better. So here we've got the input is greater than 18, but what we could say is greater than or equal to 18. So if we run that, that one should work, and I'll show another way as well that we could have done it as well. Excellent, so that's passed, that's really good, so I'll OK that. The other way we could do it is if we say input is greater than 17. Now obviously the next whole number after that is 18, so that's why it would evaluate to true and then say that you are an adult. So that's just another way that we could look at doing things. Okay, so let's get this one closed down then. Head back to here. Let's see, so there we go, that one's done. So more conditionals. So now we've got an else if, which is a really, really useful tool. In the case of multiple conditionals, we use the else if command. The command else if is like else, but with an additional condition. Else if follows the if condition, and they may be multiple. So here we've got our initial condition. So if number is equal to 1, we'll do this. Else if number is equal to 2, we'll do this. Else if it's equal to 3, we'll do this, and then else ends up sort of being like our default in the end. Okay, and then this is output into the number must be 3. So this is running through multiple different checks, multiple different conditions, until it reaches the most appropriate statement. Okay. So we've got this that we can follow through with as well. So here we've got number is equal to 3, and then we're progressing through the conditions until we meet one that matches. There you go, and you can see the output down the bottom there. Okay. Write a program that prompts the user for 2 integers and prints the larger of the 2. If the numbers are the same, then the program informs us about this as well. Okay. Right, let's ask into this. Go to our Netbeans. So we're going to do larger than or equal to. So let's pop that there. Just actually, I should probably grab this instead, shouldn't I? Really. Let's take that and put that in there. Okay. Oh, that's long, isn't it? Let's put that on a new line. There we are. Okay, so write a program that prompts user for 2 integers. Okay, so we're going to need our prompt. So the first one is give first number, so I'll just cut that. So we'll do system out, give first number, and then we'll store that in an integer. So we'll say int 1 or in1 for input 1 is equal to scan.nextInt, and then we need another prompt. And then we need another prompt for the second input. So we'll do sout, give the second number, like that. Now we'll need another integer. So we'll say int2, or in2, just to keep it in line with the other one. And that will be scan.nextInt. There we go. Okay, and then we're going to need to look at our conditionals. Okay, so we'll say if in1 is greater than in2, then we can say system out greater number is in1. Oh, hang on, so it actually wants us to print out the number, doesn't it? So greater number is, and then plus in1, like that. Then we need our else if. So we're going to put another condition here, so we can say in1 is equal to in2. And we can system out that they are the same, numbers are the same. So I'm just going to flick back here just so we get the correct string, literal, that they're expecting. Let's paste that in there, and then we can do an else that says greater number is plus in2. Okay. So I've never done it this way before, so we'll just have to have a look and see what happens. But the sort of thought process behind that is that the conditional will stop depending on the first condition it reaches. So if it reaches here, none of this code will run, and that's fine. If it reaches here, then this code won't run. But if it doesn't meet any of these first 2 conditions, or either of these first 2 conditions, then it will print out this third option here. So let's have a run of that and see what we get back. Lovely. So that has passed, and probably as you've noticed now, there are a lot of ways to achieve the same solution. So we could change this solution to say if in1 is less than in2, then the greatest number is in2, and then else the greatest number is in1, and that would still have the same effect. So just because your code might be different to mine, that's not a problem. If you get it working and you get the correct result, absolutely fine. So let's save that and close it, and head back to our challenges. So order of execution for comparisons. So this is hopefully going to reiterate what I said about when it reaches the first true condition, then the rest of the code doesn't run. So the comparisons are executed top down. When execution reaches a conditional statement whose condition is true, its block is executed and the comparison stops. There we go, perfect. So this example here, we've got number is equal to 5, so it comes in and sees this first condition, and it says if number is equal to 0, which it's not, so it doesn't even look at that. Else if number is greater than 0, which it is, so it will print this out. Okay, so it won't come down here because it will find this block, it will evaluate to true, it will run it, and then it will break out of our if-else statement. So that's why we're getting that the number is greater than 0, rather than the number is greater than 2 or the number is less than 0. Okay? The example above prints the string the number is greater than 0, even if the condition number greater than 2 is true. The example above prints the string the number is greater than 0, even though the condition number is greater than 2 is also true. The comparison stops at the first condition that evaluates to true. Okay? So this is a grade and points one, so this is going to be quite a big if-else by the looks of it. The table below describes how the grade for a particular course is determined. Write a program that gives a course grade according to the provided table. Okie dokie. Do you know what? For this one, I'm going to move my screen like that and like this, just so I can see them next to each other. There we go. So that's moved over as far as it can be. I'll just make the font a little larger as well. I don't know if that will help you guys at home. I'll change that there. There we go. Okay, there it is. So give points, and that's specifically what they want, so let's pinch that. So as normal, the first thing we need to do is a prompt. So system out, give points 0 to 100. We're going to need an integer to store our input. So we'll say int in1 is equal to scan.nextInt. And remember, we can do it the other way as well. So we could do value of and then dot scan. Okay, so we've got int in1 is equal to scanner.nextInt, and then we need to start our if statement. So if in1 is less than 0, we will print out lowercase impossible with an exclamation mark. So this is going to be an else if because we want to evaluate another condition. So all of these are going to be else ifs. This one could be a else though, and I'll go on to that in a bit. So I'll write this out and then I'll talk through it. Okay, so I've written that out, but I've just noticed that the output needs to have grade and then the grade next to it. So that's a bit irritating. So I'm just going to quickly whiz through and alter the code so that it prints out correctly. Okay, I've left this first one and the last one without grade written on it. Oh no, it does still say grade. Okay, that's fine. I'll quickly add those in then. There we go. Cool, let's give that a run and see how it goes. See if we pass first time. Okay, so I got an error here. And what it says is that with 0, the grade should be failed, but ours printed incredible, or mine printed, sorry. And that's because this is saying if it's less than, but not equal to. So if we change that to less than and equal to, hopefully this time we should pass. Let's see. Okay, so we've got another fail, and I believe it's because I've put this the wrong way around. So if that is the case, that will most likely mean that all of these need changing too. That's not a problem. It will only take a few seconds to whiz through and change them around. I don't know why, but I've always got the greater than and less than always get them the wrong way around. After coding for what, 4 years, I should really know better. Okay, so we've got another fail. That's fine. Let's quickly change this. Okay, so here it says with 0 the grade should be failed. You printed grade impossible. Oh, I see. So that needs to be see what the problem is. So if it's less than 0, it needs to be impossible. This one we might need to change a little bit. So we've got one condition evaluating if int1 is less than or equal to 49. But what we really need as well is something that covers all the numbers before then. So let's just quickly change this around. Okay, so I've just altered our code slightly. Not a great deal, but hopefully if we run that now, we should get a pass. Fantastic, there we go. Excellent, so that's passed. Another one done. Let's close this one down. And let's head back here. So conditional statement expression and the Boolean variable. So remember, the Boolean variable evaluates to either true or false. The value that goes between the parentheses of the conditional statement should be of type Boolean after the evaluation. Boolean type variables are either true or false. So here we've got Boolean, is it true, is equal to true. System out print, the value of Boolean variable is, and then that will be true. There we go, so there's the example there. The conditional statement can also be written as follows. Boolean, is it true, true if it is true, which it is. So this is an automatic evaluation for us. System out.print, pretty wild. Excellent, so that prints out for us. Comparison operators can also be used outside of conditionals. In those cases, the Boolean value resulting from the comparison is stored in a Boolean variable for later use. So here we've got our two integers, number 1 and number 3, and a Boolean called is greater. So Boolean is greater, and it's saying is equal to first greater than second. So that will either evaluate to true or false. Okay. So here we go with a slightly larger example. It looks like we're going through it here. So first is 1, second is 3. Boolean, is it less than? So first, is it less than second? That evaluates to true, and then they print out the numbers, so 1 is less than 3. Okay. The code in the image above has been executed to the point where the program's variables have been created and assigned values. The variable is it less than has true as its value. Next, the execution is the comparison. If is less than, the value for the variable is less than is found in its container, and the program finally prints 1 is less than 3. The modulo operator is a slightly less used operator, which is, however, very handy when we want to check the divisibility of a number. For example, the symbol for the modulo operator is the % sign. So here we've got int remainder is equal to 7 mod 2, so that should be 1. Oh, there we go, look, there we go. So system.out.print, it prints 1, because 2 times 3 is 6, and that leaves 1 between the 6 and a 7. Okay, so here are a few more examples. So 5 mod 3 is 2, 7 mod 4 is 3, 8 mod 4 is 0 because there are no remainders, and 1 mod 2 is 1. If we want to know whether the number given by a user is divisible by 400, we check if the remainder is 0 after taking the modulo of the number and 400. So here we've got int number, so this is the user input. Int remainder is equal to number mod 400. If remainder is equal to 0, the number is divisible by 400, else the number is not divisible by 400. Since the modulo is an operation just like any other calculation, it can be part of an expression in a conditional statement. So here we've got if number mod 400 is equal to 0, that would evaluate either true or false. So if it's true, it will run this line first. If it's false, it will run this line. Okay? Write a program that prompts the user for a number and informs us whether it is even or odd. Okay, so let's pinch this, put that in our Netbeans. I'm going to remove that. And I'm going to just pinch this as well and put that in here, like so. Okay. Right, so again, first thing we need is our prompt. So we're going to say give a number. Oh. And then we need to write a conditional that evaluates and tells us whether the input is divisible, or sorry, is odd or even. So we need our integer, so we'll say in1 equal to scan.nextInt. There we go, and now we need our conditional. So if in1 mod 2 is equal to 0, then we'll print out number plus the number is even. Okay. So we'll be concatenating this a bit. So plus in 1 plus that is even. So the reason it's mod 2 as well, if you remember back to the example where it was 8 mod 4, because 4 divides into 2 perfectly, there's no remainder. So what we're saying is if the number divided by 2 has no remainder, then it must be even. So if you think about the number 4 divided by 2, it would leave no remainder, so the answer would be 0, so it would evaluate to true. Okay, just going to add an else in, and then we'll say s out, and I'm just going to check what the okay, so it's just odd or even, that's fine. So we can copy this, paste that in there, and then we can say is odd. Okay, so let's just delete this here, give that a run and see what's what, see how we do. Perfect, so that has passed as well. There we go, so we've got the code there. So let's give this one a close. Gosh, I can't believe that we've done 33 of these now, or we're on our 33rd one. Okay, so conditional statements and comparing strings. Oh, so this is going to be interesting. Even though we can compare integers, floating point numbers, and Boolean values using two equals signs, we cannot compare the equality of strings using two equals signs. So here we've got an example here. First is equal to second. The strings were the same, the strings were different. So you can see that the input were both the same, but it says or evaluates that strings were different. And then here we've got another example. And this has to do with the internal workings of strings as well as how variable comparison is implemented in Java. In practice, the comparison is affected by how much information a variable can hold. Strings can hold limitless amounts of characters, whereas integers, floating point numbers, and Boolean values always contain a single number or value only. Variables that always contain only one number or value can be compared using an equal sign, whereas this doesn't work for variables containing more information. We will return to this topic later on in the course. When comparing strings, we use the equals method, which is related to string variables. The command works in the following way. So here we've got input.equals, and then we've got our string inside parentheses and double quotes. So here, enter a string, OK, missed the mark. So if the input is equal to this text, a string, so it has to be specifically this, it will print out that, otherwise it will print this. So the first question, this first section is wrong, and the second section evaluates to true because they're both the same, and that's pretty much how that works. The equals command is written after a string by attaching it to the string to be compared with a dot. The command is given a parameter, which is the string that the variable we compared against. If the string variable is being directly compared with a string, then a string can be placed inside the parentheses of the equals command within quotation marks. Otherwise, the name of the string variable that holds the string to be compared is placed inside the parentheses. In the example below, the user is prompted for two strings. We first check to see if the provided strings are the same, after which we'll check if the value of either one of the strings is two strings. So here we've got our inputs. We've got if first dot equals second, so if the two inputs compare the same, the strings are the same, otherwise they'll print out that they're different. And then we're comparing to this string literal here. So here we've got an example using variables, and here we've got a variable and a string literal. So if first is equal to two strings, it will print out clever. If second dot equals two strings, it prints out sneaky. So if we print in hello world, the strings are different. If we put in two strings and world, we get the strings were different for the first conditional, and then clever for the second. And then if we do just this, the strings are the same. Okay. Write a program that prompts the user for a password. If the password is kaput draconis, the program prints welcome. Otherwise, the program prints off with you. Okay, so we've got our inputs and what we're comparing against. So let's get back to our Netbeans. Oh, actually, I'm just gonna pinch this as well. Okay, so we're looking at password one now. There we are, so let's paste that in here. There we go, cool. Right, so we need to prompt the user. So I haven't got my prompt actually, where's my prompt? Oh, just password question mark, okay. Okay, so S out, password question mark. We need a string, so we just call it S1, which is very bad naming convention. And then we'll say scan.next line, and then we can use our if statement. So we've got just one conditional that we're comparing. So if s1 dot equals, and then we'll open our parentheses, and then we're going to put double quotes in. Okay, and then in between those double quotes, we're going to put caput draconis, like that. Okay, and then at the end there, we've got our curly braces. So I'm just going to pinch this. So we've got our regular sort of expression here, but because we're using this method, we've got the parentheses on the end, the brackets, and then in between the brackets we've got our double quotes and our string literal. So that's why there's a bit going on here. You can quite often have 6 or 7 parentheses opening and closing things off. So where possible, I'll let you know what's opening and what's closing what. Hopefully that will help. So if S1 is equal to caput draconis, the program needs to print welcome. So welcome, like that. Otherwise, the program prints off with you. So remember, because we haven't got a second condition that we're checking against, we can just use an else. So if it doesn't meet that first condition, it must meet the second one. And the second condition is going to be off with you. There we go. There we are. So let us give that a run and see how we do. Perfect. So we passed that one as well. I'm not sure if you noticed down here, I've turned on the full tests so that if there is anything that goes wrong, I can see specifically what areas are going wrong, and hopefully it will give me more of an idea of how to print them, how to fix them. So I'll close this. So we've only got 4 left until the end of the chapter. I wonder if we'll be doing all of those today. 1, 2, 3, 4. Excellent. So we're going to be finishing part 1 today. That's quite exciting. So what's next? So we've done that one. So logical operators. So we're going to be looking at and or. So the expression of a conditional statement may consist of multiple parts in which the logical operators double, shift, and 7 on your keyboard, or double, or this one, which is which is next to the Z on your keyboard, and not, which is the exclamation mark, which is shift and 1, are used. So we can make some really powerful statements using a combination of these different operators. So an expression consisting of 2 expressions combined using the AND operator is true if and only if both the combined expressions evaluate to true. An expression consisting of 2 expressions combined using the OR operator is true if one or both of the combined expressions evaluate to true. Logical operators are not used for changing the Boolean value from true to false or false to true. In the next example, we combine 2 individual conditions using the AND operator. The code is used to check if the number in the variable is greater than or equal to 5 and less than or equal to 10. In other words, whether it's within range of 5 to 10. So here we've got our prompt and our input, and then here we've got our condition check with our double AND. So what we're saying is if number is greater than 5 or equal to or greater than 5, and number is less than or equal to 10, system out print it is, and else it is not. So in this next example, there are 2 conditions that use the OR operator. So is the number less than 0 or greater than 100? The condition is fulfilled if the number fulfills one or either of the 2 conditions. So here we've got if number is greater than 0, so here we've got is number less than 0 or number greater than 100, and if it's true it is, and if it's not then it's not. There we go. So let's scroll down. In this example we flip the result of the expression in this example we flip the result of the expression number greater than 4 using the exclamation or the not operator. The not operator is written in such a way that the expression is flipped, is wrapped in parentheses, and the not operator is placed before the parentheses. So here we've got if number is not greater than 4, the number is not greater than 4, or else it will print this one. So because it's checking to see if it's not greater, the number is greater than or equal to 7. So because the number is 7, so it's obviously greater than 4, it's evaluating this to true and printing this first. Here's a table showing the operation of expressions containing logical operators. Okay, so I won't read through that, but let's have a look at this. So write a program that prompts the user to input their age and checks whether or not it is possible, at least 0 to 120. Only use a single if command in your program. Oh, so this is getting a bit more challenging. So let's copy this, go back to our Netbeans. Brilliant, and I'm going to paste that in here, and I'm just going to copy this question as well. So what we're going to do is do our S out. We'll put that there. And then I'm just going to move this down a bit. Perfect. So we're going to need an integer to store our age in, because we don't use sort of decimal points to describe age. So int age is equal to scan.next int. And then we need to do our comparison, our logical check. So we are going to write if age is, so we're going to write if age is greater than 0 and age is less than 120, then it will do this first condition. But we're going to need to put in some more parentheses. We can check, if this evaluates to true, we can do our system out. I'm just going to pop back to here because I can't remember what it was. So either OK or impossible. Right, so let's go back here. So our system out will be OK, and the else is impossible. Bro. There we are. So let's give that a run and see how we did. So we've got an error and we've got an input mismatch. So that will probably be because they're checking to see if we're using the value of method. So what we'll need to do is change this bit slightly. So we'll say integer dot value of, and then scan dot next line. So let's give that a little run and see how we do. You know what I've just noticed? Done it again. I put it in the wrong class. So if I just cut this, I must have skipped one when I wanted to see how many that we had left. So let's go to check an age. We'll paste that in there. We'll leave that for now. Let's go back to same. Okay, so our next challenge is to write a program that prompts the user for 2 strings. If the strings are the same, then the program prints same, otherwise it prints different. Okay, let's pinch this. Let's go into same, paste that in there. And let's get writing. So we need a system out, enter the first string. Oh, there's a colon on the end of that line. So we can say string s1 is equal to scan dot next line. Then we need another system out. So enter the second string with a colon like so, and then string s2 is equal to scan dot next line, and then we need to compare them. So if s1 dot equals, open our parentheses, and then we'll put in s2, so if they're being compared to one another, then we need to print out same, presumably with a capital S actually. Let's just double check, was it different? And then different, okay. And then we can put our else on, because we don't need to necessarily do another check, and we can just write different. So let's give that a run. And that has worked a treat. Excellent. So we can OK that one. Let's close that. Okay, let's give this a run and see how we do. Okay, so we've got a quick error. So it says when the input is 0, program should print OK. So in that case, we can say greater than or equal to. So if we run that now and see what happens. Okay, and we've got the same error basically, so but for this number. So we can say greater than or equal to. So let's now give that a run. Hopefully this time we should be okay. And there we go. So we've got that one passed as well. So we've only got 2 left, and then we've completed the first part. So let's see what we've got next. So execution order of conditional statements. Let's familiarize ourselves with the execution order of conditional statements through a classic programming exercise. Write a program that prompts the user for a number between 1 and 100 and prints that number. If the number is divisible by 3, then print fizz instead of the number. If the number is divisible by 5, then print buzz instead of the number. If the number is divisible by both 3 and 5, then print fizzbuzz instead of the number. The programmer begins to solve the exercise by reading the exercise description and writing code according to the description. The conditions for execution are presented in a given order by the description, and the initial structure for the program is formed based on that order. The structure is formed based on the following steps. Write a program that prompts a user for a number and prints that number. If the number is divisible by 3, then print fizz instead of the number. If the number is divisible by 5, then print buzz instead of the number. And if the number is divisible by both 3 and 5, then print fizz buzz instead of the number. If type conditions are easy to implement using if, else if, and else conditional statements, the code below was written based on the above steps, but it does not work correctly, which we can see from the example. So we've got if if number mod 3 is equal to 0, print fizz. Else if number mod 5 is equal to 0, print buzz. And else if number mod 3 equals 0 and number mod 5 equals 0, print fizzbuzz. So the problem that we've got here is because the operator is looking for the first true statement. If we get the number 15, for example, 15 divided by 3, or remainder 3, is going to equal 0. So even if these other statements are true, it's not going to print because it's met this first condition, and it will break out of the conditional statement. It will break out of this if-else. So here we go, look. So that example is printing fizz because, like I say, 15 mod 3 equals 0. So the problem with the previous approach is that the parsing of conditional statements stops at the first condition that is true, so the check-in of conditional statements. With the value 15, the string fizz is printed since the number is divisible by 3. One approach for developing this train of thought would be to first find the most demanding condition and implement it. After that, we would implement the other conditions. In the example above, the condition, if the number is divisible by both 3 and 5, requires two things to happen. Now the train of thought here would be, write a program that reads user input. If the number is divisible by both 3 and 5, then print fizzbuzz. If the number is divisible by 3, fizz, and if it's divisible by 5, and then buzz. So let's see. So here, it's exactly the same program, but the first conditional has changed. So like they said, the more complex conditional is first, and then if those conditions are both met, then fizzbuzz is printed. If only one of the conditions is met, because they both need to be true, this will evaluate to false and it will move on to the next condition check. Okay? So a year is a leap year if it is divisible by 4. However, if the year is divisible by 100, then it is a leap year only when it is divisible by 400. Also divisible by 400. Write a program that reads a year from the user and checks whether or not it is a leap year. Okay, right, let's get this one written. So let's copy this. Look at that, only 2 left. Let's paste this in. Right, okay, so we need our prompt. What is our prompt actually? Give a year, okay. Give a year. So we're going to need an integer. So int, I'll just call it year, is equal to scan.nextInt. Oh my days. Right, so a year is a leap year if it's divisible by 4. However, if the year is divisible by 100, then it's a leap year only when it's also divisible by 400. So we need to do that one first, don't we? So if year mod 400 equals 0 and year mod 100 equals 0, so that should be our first statement. So we will say, what will we say? The year is a leap year. Okay. So then we say the year is a leap year. I think there was a full stop on the end of that. Just double check. Yep. Okay, so that's fine. So we've done that bit. And then we need an else if. Else if year is divisible by 4. So mod 4 is equal to 0. So remember, to get the mod sign, the percentage, it's shift and 5 on your keyboard. Actually, do you know what? We can combine this. I think we had to do it on one line, did we? Right program. No, we don't. Okay. So we could potentially combine this, I reckon. So if this first one is true, or year mod 4 is equal to 0. How many of those do we need? So we've got 1, 2. That's it. Cool. We can do that. And then what's the other condition? So what is it going to print out? So the year is not a leap year. Okay. Else the year, oh dear me, sorry guys, the year is not a leap year. Okay. Let's see how that's doing. So what I've written here will check to see if the code, if this first section evaluates to true, or this second section evaluates to true. If they either one of them do, or they both do, then it will print this top condition first. Otherwise, it will print the bottom condition. Right, let's have a look and see what the error is. So when the input is 100, output was give a year, the leap year. The year is a leap year. Okay. Okay, so I think we're going to have to remove this second statement and put it on its own else if. So when this is evaluating to true, so the first one was 100, so it's a leap year if it's divisible by 100 and 400, but not just 100 on its own. So it looks like this is going to have to be a second statement. So I'll write that out. Let's give that a test. So else if, okay. So I'll leave that, and then we'll put in, so we'll do a system out, the year is a leap year, else. Let's give that a run and see how we do. So I've changed the code a bit because I'm fairly sure that this should work on one line. So let's have a look. Excellent. So I think the problem was because we were evaluating this section first, or sorry, I was evaluating this section first, and then this section, so it should have been this one first, followed by these ones. But that's great, so that's another one down. We've only got one left, and then, like I keep saying, we've finished part one, so that is absolutely fantastic. So let's close this, and let us see what the next one is. Gift tax. Okay. Okay, so this one is a bit more complex by the looks of it. What's that? Okay, so this is the final one for part one, and it's to do with multiple ifs and gift tax. A gift is a transfer of property to another person against no compensation or payment. If the total value of the gifts you receive from the same donor in the course of 3 years is greater than €5,000 or more, you must pay gift tax. When a gift is given by a close relative or family member, the amount of gift tax is determined by the following table. So we've got this table here. For example, €6,000 implies €180 of gift tax. So here's the formula. So we've got gift tax at the lower limit of 100 plus 6,000 minus the lower limit times 0.8 or 8%, and €75,000 gift implies 7,100 of gift tax, which is here, so 4,700 tax at the lower limit, the input minus the lower amount times the tax rate. Okay, so this one actually isn't going to be as bad as as potentially we're making out. So the great thing about this is we can test it in individual parts. So we can write this first if and make sure this is working before we move on to this next one. So if we break this down into small parts, we'll be absolutely fine. So let's go back to our Netbeans. Let's open up the class, the Java class, and then we shall begin. Brilliant. Okay, so let's have a go at doing this. Let's quickly just pop back here. Okay, so the data type is going to need to be double rather than integer because we're working with decimal points. Okay, that's fine. Okay, let's give it a whirl. Right, so we've got our scanner. So we're going to need a system out, which I believe is value of gift. Yep. Brilliant. So let's paste that in there. copy these. That's not really any good, is it? Bro. Okay. I'm going to move my screen so I can see them both side by side. Okay. So the first thing that we're going to do is do a system out, a user prompt, and the prompt is going to be value of the gift. So value of the gift, and then we're going to need an input. So that's going to be of type double because we're working with doubles here, so instead of integer. So we'll say double input is equal to double dot value of, and then scan dot next line. Okay, and then let's think. So we can start writing out the if statement. In fact, let's do the tax brackets first. So we can write out the different tax as variables, and then we can use an if statement to combine the variables and the user input. So let's say that double, so band1 or B1 is equal to, so we'll say 100 plus the input minus 5,000, which is the lower level, and then we'll be doing times 0.08, and then a semicolon and the end of the line. And then if we do that for all of the bands, so we'll do, so I'll quickly write those out. Okay, so I've written out the tax bands, so we're going to use these in our if statement. So I will write out our if statement. Okay. So let's just increase that size. So that should do the job. Let's give it a run, see how we do. Okay, so we've got a little fail here, so let's have a look. So input was 1,424,171. So it's probably, I reckon I've done this one wrong. No, that one's right. Let's have a look. Okay, so I've figured out what the problem is. So the problem is here. This is 100,000, not a million. So let's give it a run. I must admit it took me a few minutes to spot that. So let's give it a run and see how we do. Fantastic. That is it, done and dusted. Excellent. So for those of you that have stuck with this, absolutely fantastic. Well done. I imagine a few of you are new programmers, so if you've got this far, absolutely fantastic. You're well on your way to becoming a programmer. And congratulations for meeting at the end of the first part. So I will get working on part 2 as soon as possible and get those parts out for you as well. This one, these last few bits, this 6th section, did seem quite a big jump from the previous, from the variables and calculating variables. So if anyone does any questions or queries, please feel free to put a comment below, and I'll gladly come back to you with an answer or a solution, or perhaps I can point you in the right direction of a good resource to read or a good video to watch that will help. But failing that, thank you very much for watching again, and hopefully I will see or